Okay, so this is the second set of notes for slope fields. I hope that you were able to print them out. We're going to have to make a couple of changes, but it basically just starts out by saying that a slope field is a graphical representation of a differential equation. So that's a perfect way to define it. Graphical representation of a differential equation is what a slope field is. You can kind of see how this one, like maybe the function goes like that, or maybe the function goes like that, okay? It wouldn't do both because then it wouldn't be a function. It'd fail the vertical line test. But you can see that you might have it here or you might have it here. You can kind of see that the way the slopes take it. So that's the thing that you want to notice about a slope field. You're imagining what kind of functions that would be. So I'm just going to take those off of there. But let's go ahead and look at this first example. This is our slope field. Now, remember when we were doing differential equations and we would separate them? You don't separate a slope field. You just leave it. There's your derivative, 3x minus 2. The only thing I would change on this problem is that I would put x and y, but it doesn't matter because there is not a y in the slope field, right? So you really only needed x, and it was going to be for all y, but I wanted to make sure that you remembered that those x's that I'm going to choose, it's not going to matter what y we choose. But let's go ahead and just do -2, -1, 0, 1, and 2, okay? And then we would calculate, we've got -6 minus 2 is -8 for the slope when it's -2. -3 minus 2 is -5. This one would be -2. If it's 1, it would be 1. If it's 2, it would be 4, because that would be 6 minus 2. And so now, at x equals -2, it doesn't matter what the y is. So for all these y values, when x is -2, you've got a really steep negative slope. So I'm just going to make it, pretty steep there, -8. And then you've got -5. They're not going to be as steep, but still pretty steep. -2. We're just putting a -2 slope at each one of those. And then at 1, it's +1. And then +4. Okay, so that's what that slope field is going to look like. If this is a slope field that you're trying to figure out, okay, what kind of function do I have here? And so if you wanted to separate them, just so you can find the connection between these things that we were doing here, if you wanted to separate them just to kind of see like, okay, this is the slope field for some function that I don't know what it is. I only know the derivative of it. I don't know what it is. This would give you 3/2 x squared minus 2x plus c. So this is actually one of those skinnier parabolas, but it's upward facing, and I'm thinking that I'm just going to use my highlighter here, that like right here might be my vertex, and it might be a little bit skinnier, something like that maybe, or something, we could, if we had a point, it'd be here somewhere, but I'm thinking that vertex would be there. So that's what I wanted you to see, that like the connection between the two things. If we can't solve a differential equation, then you are looking at the slope field, imagining what that original function would look like. That's what we do when we have a slope field. And so for example number 2, it has an x and a y, and so I'm just going to move that -1 over and then divide by y, so that I can see what that differential equation is. And then this one, since it has an x and a y, we absolutely needed x and y. Because if we, say I'm going to do -2, -2, -2, -1, -2, 0, -2, 1, -2, 2. Those are all different points, and you're just doing that one vertical line there. But so if I did -2, -2, this would be a -4 on top divided by a -2, which would be a +2. If I did the -2, -1, this would be -4 over -1, which is +4. Look at this one, -2, 0. If I put a -2 in for x and a 0 for y, this is undefined. So there is no slope there at that point. -2, +1 gives me -4 over +1, which is -4. This is -4 over 2, which is -2. And then we could do the -1, -2, -1, -1, -1, 0, -1, 1, -1, 2. And so for that one, we would have -2 over -2 would be a +1. This one, -2 over -1 would be also a, or I'm sorry, yeah, -2 over -1 would also be a +1. Oops. Sorry about that. This one's going to be undefined because y is 0. This one's going to be -2 over +1, -2. And this one, -2 over +2, be -1. And we've only done, like, do you see how many, how this can get kind of out of hand? Now I would probably do, if x is 0, -2, 0, -1, 0, 0, 0, 1, 0, 2. I'd probably do that. Then, and find the slope for each one of those points. And then, 1, -2, 1, -1, 1, 0, 1, 1, 1, 2, and find all those. And then 2, -2, 2, -1, 2, 0, 2, 1, 2, 2. And find all of those. So these would be your x values, and these would be your y values. And then you would have your dy dx values for your slope, okay, to get ready for your slope field. Here's our x values, our y values, and our dy dx to get ready for your slope field. And this one, our x, our y, and then we would need our dy dx values. For this example number 2, you're just putting in little mini, for what, -2, -2, a little +2 slope, and then a +4 slope, and then undefined, and then a -4 slope, and then a -2 slope. I think I mixed those two up. This one was supposed to be steeper than that one. There we go. And so at -1, -2, we should have had a +1 slope, and then another +1 slope. I want to check that one though. -2 over -2, -2 over -1. Should this -1, -1, that should have been a +2. Sorry about that, guys. So -1, -2. Oops. No big deal. -1, -2 should have been +2. Okay. So, and then -1, -1 should have been +1, then undefined. -1, 1 is a -2, and then a -1, okay, for that -1. And if you notice at 0, when x is 0, this is always going to be 0 because you have 0 in the numerator. So here, all of these, actually, except for that one that I just accidentally put there because you can't have division by 0, so that's going to be undefined. These are all slopes of 0, okay? And then for these values at when x is 1, we have 2 here. This one was undefined. 1, -1 is -2. 1, 2, oops, 1, 2 was 1. 1, 1 was 2. And 1, -2 is -1. And so for these, we've got 1, -2 is a -1. And then 1, -1 is a -2, a little bit steeper. And then this one's undefined. And then 1, 1 is +2. It's a little steep, sorry, +2. 1, 2 is +1. Okay, so that's that one. And then the last one where your two, I've listed these differently on my paper. That's why I'm getting crazy here, and I didn't want to go through and figure every single one out again. I was trying to make this video faster. So negative or +2, -2 is going to be a -2 slope, and then a -4 slope, and then undefined, and then +4, +2. Okay, so that's what that is, kind of a cool looking slope field. But that's what that one would look like. It's almost like a burst. And then we go to example number 3. Consider the following equation. dy dx equals -x over y. And it said compute it at each of these. So we've got -1 over 1, -1. +1 over 1, 1. And then we've got negative times negative is +1 over -1, -1. And then negative times 1 over -1 is a +1. So that one, dy dx is positive in which quadrants? Because you're imagining that this one would have been in the first quadrant, this one would have been in the second quadrant, this one would have been in the third quadrant, and this one would have been in the fourth quadrant. So you can see that it's positive in quadrants 2 and 4, and negative in quadrants, 1 and 3. And then we're going to do the same thing here. If I use that -x over y, every single one of these is undefined. And the reason why is because they all have y values of 0. So now if we were looking for this slope field, if we were looking for it and we saw that, you know, everything's undefined where y is 0, we know that our differential equation would have y in the denominator. And so the slope as undefined is like x equals a. Any vertical line, and the slope is 0 is y equals b, any horizontal line. And so then for the next one, this one would be -1, -1, -1, and -1. And what equation would express dy dx equals -1? Well, that would be y equals x, and or dy dx equals +1, y equals -x. Okay, for all of those values. So use the grid at right to sketch the slope field for the values calculated for A, B, and C. So they want us to take those values that we calculated and put them at like 1, 1. They want us to do -1 slope. And at -1, 1, they want us to do +1 slope. And undefined everywhere where your y value is 0. And so that would be all along here on the x-axis. And then we had 2, 2. We had a -1 slope, and -2, -2, we had a -1 slope. So what ends up happening here is that you end up with this slope field that looks like this. And I'm just going to go ahead and let you guys kind of put those in, because this is what it ends up looking like when you put them all in. I guess I can put a couple more here. And if it passed through the point 0.02, that's this point up here. And I think I'm going to do that in a different color. You can kind of see this is going to be a circle. And if you take your dy dx equals negative x over y, and multiply by y on both sides, multiply by dx on both sides, integrate, we've got 1/2 y squared equals negative 1/2 x squared plus c. And we can put our, we can put our, point in, x is 0 and y is 2, so 1/2 2 squared equals negative 1/2 times 0 squared plus c. So our c is 2. And then if we put 1/2 y squared equals negative 1/2 x squared plus 2, and then multiply by 2, multiply by 2, multiply by 2, we get y squared equals negative x squared plus 4. And then if we move our x squared over here, we get the equation of that circle. X squared plus y squared equals 4. So it says, explain what happens to the slope values as you move from left to right with a fixed y value. And so for that one, if y is greater than 0, then dy dx decreases. If y is less than 0, then dy dx increases. And explain what happens to the slope values as you move up from the x-axis with a fixed x value. So dy dx is undefined at the x-axis and decreases as you move up. And then this gets us to the most important part, I think, of this little piece. Well, these next two things that we're doing are going to be the most important. What I want you to do, you're supposed to match these up, and I think that this is hard for some kids, but think about your domain here. It's going to be -2 to infinity, and so is there a slope field that stops at -2 and doesn't go any further to the left? And I can see that that is D, okay? There's also letter E slope here, and think about what is going on with that one. It has, if you look across, it has every single thing is the same horizontally. Like if I look across horizontally on letter E, they're all the same. That's going to be your hint that your Y is the only variable. Is there any that have Y as the only variable? Okay, this one and this one, 5 and 6. Okay, and then think about if your Y is your only variable, which one is not capable of having negative Y's? And that would be this one. There's no negative Y's there, so I know that D and E are taken care of now because I figured out what those were. we know what the derivative of what derivative is cosine. So I know that this is y equals the sine of x that I would be looking for. And so I can see y equals the sine of x here in h. This one, you can see how this would be like, you know, oops, I didn't draw it the greatest there. That doesn't look like sine. But you can see how, because gosh, it's hard to do with this little pen, but you can see how this looks like the sine function. So this one's going to be h. Another thing to look at is, which ones are x only, because they're all the same vertically. So this one would be all the same vertically. This one is not. This one is not. We already took care of that one and that one and that one. All the same vertically, not. All the same vertically, not. Okay, so this one that is all the same vertically, it probably only has x in it. And the only one left that has x in it only is 2. So I think 2 is A. Because it's all the vertical lines are the same, so that means the differential equation only involves x. So now, this one B, it looks like it's undefined here where y is 0. Is there one that would be like that for letter B? Or maybe those are just zeros. Maybe that's just little slopes of 0 here. That could just be little slopes of 0, but ooh, look, there's slopes of 0 here too. I mean, I can see these slopes of 0. And these must be slopes of 0 also, because I don't see another one that we don't have done yet, but this one right here would be the one that would give us zeros on both the x and y axes. Because if I put 0 in, I'm going to get 0. So all those points that have x equals 0 and y equals 0 are all going to have slopes of 0. So we've got B, we've got A, we have D, E, and H. So we have 1, 2, 3 left. Does anything look like anything that you would think of for for sine of y plus x? That one, look how this kind of looks like a sine of y. Isn't that weird how it kind of does that? That's going to end up being this one. You can also look like where their horizontals are. Like anytime you see that horizontal, try and figure out which one that corresponds to. For number 6 here, y squared plus 1, that one, when it only involves the y value. So is there one that has all horizontal? Look, these are all the same horizontally. And so this one, letter C, since they're all the same horizontally going this way, all the same, all the same, all the same, you're going to have this one. And then the only one that's left for the cosine of x plus y is F. And that one does look like a kind of a crazy one. But that's kind of how you decipher it. It's not the greatest thing to try and explain, but it is, you know, you're just using everything that you know about those. All right, so now we're going to separate this differential equation. And I didn't have any y's, so I'm just going to make this dy equals 1 over x plus 2 dx. I'm going to integrate. Y equals the natural log of the absolute value of x plus 2 plus c. And they gave us a point. They said the y is 1 when x is 0. And so 1 equals the natural log of 2 plus c. So 1 minus the natural log of 2 is my c. And therefore, my y is going to equal ln, absolute value of x plus 2, plus 1 minus ln 2. And if I've got the 0.01 here, I'm going to go ahead and put this in a different color just because it's hard to see. You can see, based on this slope field, that your function is going to go something like that. Okay? And then how to distinguish between slope fields. What strategies and trends do you look for? So we've got a few suggestions here. Number 1, dy dx has x if slopes change left to right only. And that would mean that they're the same vertically. And number 2, dy dx has a y if slopes, well, I would say same vertically if it's only x, right? So slopes change up and down only if it has a y, and like I said, same horizontally if the only thing that they have is a y. Okay? If it's only a y, it would be the same horizontally. Number 3, dy dx has x and y if the slopes change in both directions. And number 4, find what conditions will make either dy dx 0, so you could look at, okay, what makes it 0? Dy dx have positive slopes, dy dx have negative slopes, dy dx be undefined. We thought that one time it was undefined for the y, but those were just slopes of 0 that we couldn't see. Okay, so this helps. There's a lot of well, not a lot, but you can find multiple choice questions that will give you choices for slope fields and say, okay, hey, which slope field matches this differential equation? Or it might give you a slope field and say, okay, which of these differential equations match that slope field? So it is something that you're going to be asked, something that I could ask, or something that the AP exam could ask. You should now be ready to do your slope field homework.